Good afternoon and welcome to webinar. Just a reminder, this event is being recorded, and to put all questions in the chat, and the Q&A portion will be at the end of the event. I would like to go ahead and introduce our speakers for today. First is Ron Williams, who serves as the Deputy Director for cloud.gov. Prior to joining the TTS at GSA, he was the Director of IT for the USDA Communications, working on USDA.gov, ChooseMyPlate.gov, Farmers.gov, and other public-facing websites. Our other speaker is Carlo Costino, who serves as a platform operator for cloud.gov. He previously served as a software engineer and engineering supervisor within TTS's 18F, where he partnered closely with the Federal Election Commission on the modernization of FEC.gov. And now I will pass it over to them.
Welcome, folks. I'm excited to share some information today about cost optimization of cloud services within the federal government space. I'll tell you a little bit about our team. Cloud.gov was founded to enable agencies to improve reliability, reduce costs, and better support public services through cloud adoption. Today, we'll talk about using cloud services in a cost-effective manner, leveraging the cloud to support delivery of modern customer experiences, and balancing those capabilities with monitoring and policies to deliver efficient platforms. Agencies across the federal government are seeking to get more value from every part of their operation. These include areas such as customer and public support, process improvements, and overhead costs. We've heard from the community across the federal government, contractors, and federal employees of agencies like USDA, EPA, FEC, and even GSA, who are looking to streamline and derive the most value from their cloud investments. At cloud.gov, we're working to help agencies achieve this goal. So how are we doing that? First and foremost, we assume positive intent based on the technical and historical experience within our engineering teams. We involve them in our conversations and solicit their feedback when determining how best to approach this work. Engineers and developers are our allies. They help us identify workloads that impact costs and operational efficiencies. With their partnership, we're able to focus on opportunities with high return on investment. Some cost increases are not actionable. Some infrastructure optimizations intended to reduce costs have the opposite effect. And some cost savings come at the expense of platform stability and capability. Your engineering team can help avoid these pitfalls and ensure cost savings measures have a positive effect. And just remember, it's critical to look at services and systems individually to meet agency cloud goals. Within this presentation, graphs presented demonstrate the actual value gained from the service optimizations we share today. Here's one of our first services analyzed on our path towards optimization. EC2 instances are virtual machines on AWS. At cloud.gov, we deploy customer app instances to a shared EC2 cluster. Common pitfalls include inefficient use of purchased reserved instances, use of prior generation instance types, and over-provisioning of platform components. In these graphs, we're showcasing the impact that improved utilization of reserved instances had on our costs. This is an example of how we've drilled down to find the relevant cost information for our EC2 resources. As you can see, we have significantly reduced costs. Let's talk about another service. S3 buckets provide general purpose file storage in AWS. With cloud.gov, customers can store content for their website or app. Using AWS CloudWatch and Cloud Checker reports, we identified unusual patterns in the cost concentration across our provisioned S3 buckets. This was a real puzzle. We worked with cloud.gov customers to delete unused data by applying lifecycle expiration policies. Additional optimizations include reconfiguring apps to reduce the use of expensive tier 1 type requests with the help of one of our engineers, and then applying paid metrics to get more information. This is an example of how we enabled those paid metrics for our S3 buckets. It's not the most obvious setting in the console, so we wanted to call this out specifically since this configuration allowed us to identify our unusual usage. Let's talk about a couple more optimizations your team can take to improve cloud delivery. My colleague Carlo will take us through RDS.
Awesome, thanks, Ron. So far we've covered EC2 and S3. So we're going to talk about one of our other commonly used services on cloud.gov, RDS. RDS instances are managed databases using common engines such as MySQL and PostgreSQL. Customers on cloud.gov use RDS to store and maintain data sets. One thing we've noticed is common provider pitfalls include one-size-fits-all approaches. We have found that it's important to provide a wide selection of easily accessible and changeable instance types. Once appropriate instance types are available, cloud engineers leverage a variety of dashboard tools to help users right-size their databases for cost-efficient operation. And so to help with right sizing, we routinely deep dive into metrics for each instance deployed. Our team sets monitors to automatically identify anomalies across the platform. Some tools we use include CloudWatch, Cost Explorer, Cloud Checker, Kibana, and Prometheus. For example, displayed on the right is a collection of dashboards we have configured that shows database usage information at a glance. We can quickly identify instances that require further analysis just by checking this one screen. This has helped us greatly in identifying which instances to really target our focus on this. While your dashboards will be custom tailored to your data sets and specific needs, leveraging common visualizations helps organize the data into manageable groupings that can help spot trends and outliers. Once you've identified the major trends and outliers, focus on the metrics that will yield the most insight into where costs are accrued. If in doubt, start with more than you need to get a broad picture and then refine your filtering as it becomes clearer which data is relevant to your needs. So for example, when we began searching for our outlier S3 costs that Ron was discussing, we enabled paid metrics on a handful of buckets and didn't find anything initially. We then applied the metrics on cloud.gov's top 100 storage buckets and successfully identified the inefficient deployments. These are just some of the strategies that we recommend based on our own journey of cloud optimization. So work to optimize costs is ongoing and incremental. These optimizations are just the start of a broader effort that agencies must consider to ensure costs are under control and also providing maximum value to the general public. So where do we go from here? Well, there are several areas for future improvements. First, optimize RDS deployments through auto-scaling and offer even more instance classes for customers to choose from. Next, enable reserved instances for brokerage services, including RDS, Elasticsearch, and Elasticache to drive down resource costs further. Another consideration, implement sensible default lifecycle and versioning management for all storage services, including S3, EBS, and others, to prevent retention of unneeded data, which contributes to rising costs. And finally, replacing bespoke services with stable brokered services, for example, Kubernetes cluster, to reduce O&M costs. So to summarize, identify your data sources and monitor them, work with your team and customers, and prioritize prime opportunities for cost savings. So now I will pass it back to Ron, who's going to talk about what this means across the federal government.
Thanks, Carlo. Now let's talk about how the real world applications have benefited the federal community taking these approaches that we've talked about. airnow.gov is a public service providing access to fire maps and air quality metrics. During wildfire season, cloud.gov used the cost saving strategies we shared today to help EPA optimize their cloud usage. When airnow.gov traffic grew from less than 2 million requests per day to over 80 million requests per day, becoming the highest traffic web page in government, EPA incurred no additional costs while also remaining online during this critical period. It's a really exciting time. This just occurred in the last couple of weeks for their team. And so we've been monitoring those. And as I show on the graph here, you can see that they're still seeing a large amount of traffic, but leveraging these strategies, we're really able to keep those costs down for these services. I'll talk about what this actually means, for cloud.gov, but as a cost recoverable service, we pass these on to our customers. Back in March, as we talked about earlier in the presentation, we audited our EC2 service usage. We talked to our engineers to see whether there were things that we could changing the instance types to use the newer lower cost services. We were able to, in April, then scale down our excess usage and reallocate our pre-purchased reserved instance types. That was seen on one of the earlier slides where the graph went up quite a bit on the reserved instance usage. And then continuing into May, we completed that work and then also reached out to our customers based on the data that we saw in these dashboards that we had built out in order to request that they remove unused database instances. So even internal data centers, but also cloud service providers will have services that are provisioned and unused because it's been transitioned away from, or it was used as a backup and restore, but not used further. And so we really helped users based on the data and looking at the outliers of utilization to reduce costs of the databases under RDS. And then in June, we continued auditing the RDS usage, and then began developing a tool that allowed customers to change between instance types in a single command within cloud.gov, and then of course brokered against AWS. So we could actually change the instance type in a matter of minutes. Again, once we added that in July, we had a slight increase in costs because we were doing lots and lots of testing. We also applied the S3 optimizations in July, and that allowed us to only see just a moderate increase. And the S3 optimizations were mostly around eliminating about 90 terabytes of unnecessary data and backups that were existing for some customers, and then also reducing the tier 1 requests by disabling some apps that weren't necessary, and also cleaning up some others as well. And then in August, we finalized the scale down of the RDS instances. We found, this is really important, that we found about 140 instances that could be scaled down. And so as you're deploying on cloud, initially you may want to select a database that's a little bit larger, especially as you're doing active development or heavy development, and lots of database imports and exports and changing your schema. But once you get into production, depending on the overall profile of your app, you may be able to scale down. And we found that was the case in a large number of RDS instances deployed on cloud.gov. So what that really meant is, we're outlining our monthly infrastructure costs here for the entire cloud.gov infrastructure for the services we support. And as a result of these optimizations, we've realized $540,000 in annual savings that gets passed on to the federal government community as a result. So wrapping this up, I just want to thank Carlo and the folks at digital.gov who coordinate these learning opportunities. We encourage you to take a look at the future digital.gov university events to continue learning more from your colleagues across government. Pass it over to Carlo.
Thank you. And if you'd like to learn more about cloud.gov, you're welcome to join us during weekly office hours or by emailing us at the email address there, inquiries@cloud.gov. And we thank you for taking the time to be with us here today.
All right, so Carlo and Ron, there's a question in the chat asking, did you use a tool to collect the operations activity? If so, what tool did you use?
Could we have a little more clarification, or Carlo, do you know what they might be getting at there? The operations activity?
I was just about to ask a clarifying question. In terms of operations activity, what we're doing on the platform side itself and how we're tracking our work. How do we identify usage of the data? Was this specifically with S3 or just in general? In general. Ron, you could speak a bit more to this, I think, but let me see if I can start this off. For the most part, it was just monitoring the request information and the flow of data in and out of the system. And so like some of those graphs that we had shown earlier, I think in particular like CloudWatch was a big help here. We were identifying where a lot of the bulk of our traffic was flowing in through the system, in and out. And that was a key indicator for us in terms of where to start targeting our efforts. We knew off the bat, I wanted to say like with EC2 and just the applications in general, that we had to start there and take a look. But once we, took a look at those things and then started focusing on, now the applications are in a better hosted environment there. What's actually going on with them? What are we seeing? What are the general usage patterns across the board? That's where it really started to become clear that S3 and RDS in particular were areas that we should focus our efforts.
Touching a little bit more on that. As I have a screenshot here within AWS CloudWatch, you have the opportunity or option to graph multiple metrics at the same time. So we have a large number of instances, and associated with those instances are multiple metrics. You can think the traditional ones like CPU, bandwidth utilization, memory utilization, but also service level information and custom metrics that we pipe into CloudWatch. So for example, when we were looking at ways to scale down our EC2 instances on cloud.gov and to right-size those instances, we graphed all of our entire cluster CPU utilization at the same time, and then also graphed all of the memory utilization across our cluster at the same time. And we did that on a historical basis over the last 6 months to make sure that we weren't, say, in a unique lull when we decided to perform those scaling operations. And also just to make sure that we, as we're seeing additional apps deploying onto the cloud, that, we're not scaling down right now and then having to scale up in a few weeks, because there is a cost to scale down services and scale up services. So we really, leverage as many metrics as possible. Sometimes it is, I think that we mentioned actually on the slide, if in doubt, start with more metrics, get a broad picture. You may find nothing in some cases. There were plenty of times where we looked and took a critical eye to each one of our services that were deployed, and sometimes just found no optimizations that were possible. But there are other times when, we were able to see that, we're only using 30% of our capacity, and by scaling down just by one instance type level, I should say, that we could increase our utilization maybe to 40 or 45%, which is still very reasonable considering the additional capacity that we have on the environment. Did that answer your question, Michelle? Thanks.
Are there other questions for Ron and Carlo? If so, go ahead and drop your questions into the chat. Okay, I don't see any other questions coming through the chat. So Ron and Carlo, any final closing thoughts?
No major ones. Our team is open to collaborating with other agencies, and if any questions come up after this call, feel free to email us at inquiries@cloud.gov. We're happy to hear from the federal community and discuss further.
Yeah, and I'm going to apologize right now because as soon as I'm getting ready to talk, there's going to be a siren. But yeah, just like we had mentioned before too, this is absolutely an ongoing and iterative process for ourselves. So we're constantly monitoring and checking things and seeing where other opportunities come up that we can further improve the service and reduce our costs while still maintaining platform stability and just offering the best value we possibly can to everybody.
We may schedule another one of these as we discover more and pass this information on to our colleagues in the federal government. And if you have anyone who's on the line who is working with cloud services, if you've found some optimizations that you would like to share with us, we welcome those, and collaboration is key to the community that we would like to foster in our office hours, and also just as participants in the open source community.
All right, Ron, Carlo, thank you so much. Thank you everybody for joining us today.
Thanks everyone.
Thanks.
Thanks for having us.